7 is linear inequalities in two variables. In two variables. So first of all, what's an inequality again? What's an inequality? Think back, chapter 1, inequalities. X is greater than 4. What does that mean? What kind of an inequality, or how do you explain that?
That means that X can be anything that's over 4. So it can be 4.1 or 4.0001.
Good. So any number greater than that, or greater than or equal to, or God bless you, or less than that, or less than or equal to. So it's a statement that gives us a solution set. Agreed? You don't get just one solution. So the example, like we talked about conjunctions and disjunctions. Conjunctions, we knew that there was an and statement, right? So X was between 3 and 7. So we said like X or 3 less than or equal to X, less than or equal to 7. Those were inequalities in one variable. It was only X. We are now going to look at inequalities in two variables. Okay? It is very similar to what we did with the overlapping of sets. Remember how we drew a number line and we looked to see where our answers overlapped and we knew that that was our answer, our overlap? That's what we're going to do today. Keep that in the back of your mind. That's why I teach it that way, because you might not need to do that with one variable. You might not have to see the overlapping, but I do that on purpose because it's going to come up here. So keep in mind the overlapping of two sets. So we're going to look at the similarities between graphing lines and inequalities. So you're going to use what you've learned for lines for inequalities to graph. And then we're going to look at shading regions. That's the overlapping of two sets. So let's take the first part here. So all I want to do is graph this. Now, all you need to do to graph these is simply graph them like they're lines. Graph them like they're lines. But looking at the less than or equal to sign versus a less than sign is important. So I want to differentiate real quick between the two. So if the problem had said this instead, these are different solutions. What did we do? Think back. Number lines. What did we do when it was just less than? When it was just less than?
We drew a circle, but we didn't have
Yeah, open circle. But when it was less than or equal to or greater than or equal to, what do we do to that circle, everybody? Yeah, we shade it in and we close the circle. Close circle. Now, the analogy to that is the following. Here's what it is. When it's less than or equal to or greater than or equal to, like we have in the problem, it's a solid line on your graph. What do you suppose would happen when it's like this? When it's like this? It's a dash line. It's a dash line. So again, write that down if it doesn't make sense. You know, if you just keep that in the back of your mind. When it's just less than or just greater than, we're looking at a dash line showing that that's not part of the solution set. Just like an open circle said that. Remember, an open circle means that point is not part of the solution. A dash line indicates the same thing. It sets up a boundary. It sets up a boundary, like a wall. Okay? So if this were like my boundary here, everything inside of this wall might be my solution set. But the wall is or is not in the solution set based on whether it's less than or equal to or just less than. Okay, if it's less than or equal to, the wall or the boundary is part of the solution. Solid line. If it's just less than or if it's just greater than, the wall or the boundary is not part of the solution. Hence, you have a dashed line. Okay, a dashed line. So to graph something like this, you could use any method you'd like. Okay, you could use intercept method. You could use slope intercept method by solving for y. That's probably all the two methods I would use for this one. Question?
Could you just find the slope using negative a over b?
Yeah.
Plugging 0 for x?
Yeah, absolutely, to find the y-intercept. So it's in standard form, so Summer makes a great point. Negative a over b is the slope. So the slope is negative a over b. So the slope is simply 3/2. Now if you want the y-intercept, just set x equal to 0, and we could use the slope and the y-intercept. Okay, so here's the slope. To get the y-intercept, set x to 0. So here's what you're doing. In your mind, you're crossing this off. Let me erase this, by the way, so we're not confused. So all you're doing to find the y-intercept is just setting x to 0. So divide by negative 2 on both sides, you get y equals negative 4. So the y-intercept in this case would be 0, negative 4. So sure, you're absolutely right, Summer. That's the third way of doing it. Good point. And that's probably the best way. Okay, you could find the intercepts x and y and graph with intercept method. You could solve for y and do that, or you could just do simply this. So let's take a look at our graph. Well, actually, let me load it. I've got the graph saved. You could do the same, please. So insert a graph from your picture roll. Nope, I don't want that. By the way, ever see this? This is cool. You can take a picture. Isn't that cool? Yeah. In physics, when we do diagrams and I have people come up for demos, I end up taking a picture and we draw like force diagrams on their bodies and stuff. It's kind of cool. I'm trying to import an image though, so let me go back.
Take a pic of us and put it.
Take a picture and import it.
Please? Yes, come on. Just put it right. That's yours.
All right, so I'm gonna insert this. Where's my?
You could just make your paper like a certain color. Like, you could just make it. Can you make your paper like us? Wait, no, you can't.
I can't change my setting to graph paper like you can.
Yeah, why? That would be so like, you can do that on the.
Because the PDF overlays the template. So when you change it to graph paper, it's behind the PDF. Which is why we did this last time, Tori May? Imported the image instead? That's the reason, yeah. But if you're doing homework and stuff, you could use just regular graph paper, as long as there's not a PDF on top. So let's go ahead and graph this. Our y-intercept is -4, our slope is 3/2. So we go down to -4 down here for the y-intercept. Let's label our axes also, and label our increments. Okay. And then we have a 3/2, so I go up 3 and over 2. Up 3 over 2. Oops. I can go down 3 and over 2. And I clearly know that this is going to go positively because it's a positive slope. So the graph rises as it goes from left to right, just to check that in our mind. Now remember, if you need to, use your ID card to make a straight line. It might help you. I'm going to do my best. Okay? So that's what our line is going to look like. Why did I make it a solid line again? Dave? Because it's less than or equal to. It's less than or equal to. But now, this is no different from a line. There's one more step. What did we do? I know you might know, I'm asking a different question. What did we do with linear inequalities in one variable when we had a number line and we wanted to know which region the solution was in? How did we figure out which region to shade?
You shaded, if it was less than, you shaded the high number, and it was greater, and you shaded the number.
Okay, good. And what else can we do? There was one other thing we could have done. We could have tested something, remember? We could have tested a point to see if it were true or not. On the number line, if we had an open circle here and an open circle here, we tested the 3 regions. Whichever one proved to be true, we shaded that region. That was the graphical solution method we did. So it's the same thing here. So you need to test a point on either side of the line. If it's true, you shade that side. What's the easiest point to test?
The origin.
The origin. Why? They're zeros. Plug 0 in both of these cases into the original. You get 0 is less than or equal to 8. Is that true?
Yeah.
It is true. Plug in a 0 here and here. You get 0 minus 0 is less than or equal to 8. That is true. Which means that the solution lies on the side at which the origin is on. So shade everything on this side. That is your solution set. Okay? That's how we do these problems. Ferdinand.
Once again, you can use my head turning method. And if you turn your head to the left, your head turning above, because it's an A, so you go above. So anything like
Be careful though, if the sign switched, it would be below.
yeah, exactly. And then if it's like 3x minus 2y is greater than
I mean the sides. Like if y is on this side and the number's on that side, it's going to be wrong. It's going to be the opposite.
yeah.
But you can, if you remember that, sure, absolutely.
That's when you turn to the left.
Oh,
The
okay.
side,
So I have to remember to switch the rule depending on the way.
yeah.
That works. The reason I'm teaching you the testing points is because in calculus, you use this test point method a lot. Okay? So you understand it, but that is a good shortcut to remember, absolutely.
We learned this last year, and it was whatever side the y is on.
But I don't want you to memorize because things are going to change. And we're going to have quadratics. We have to shade on sides of quadratic. So things do change. But that is a good technique to remember, yes. So Ida's saying here, take a look. If you moved it over, you're going to see that in this case, if you move the y over here to make it positive, because you want a positive y, you'd have to move the 8 over. And then you would get y, and reading from right to left, is greater than, which means shade above. That's fine. You can remember that for now. But things do change. So please understand the idea of testing a point. You may use shortcuts, that's fine, but you need to understand how to test a point and show me you can do that. Check with these other methods though.
In school last year, if you make that into y equals mx plus b form, wouldn't, when you flip the sign, we just learned that when the sign is greater than it's shaded
That's
up.
what Ida just said.
Yeah, when wouldn't that?
If we have quadratics, if we're looking at systems of equations, we want to test points. It's a lot easier, and I'll show you in a moment. So just have faith for a little bit. We'll see it by the end of this period.
Always plug in the origin?
Absolutely. Unless it goes through the origin. Guys, unless the line goes through the origin, always use the origin as your test point. If the line goes through the origin, though, you can't use it. You have to use something on the side of it. In that case, I would use 1, 1, maybe as my point, right? Easiest after 0, 0, unless it goes through 0, 0, and 1, 1, which is just y equals x. Right? That's that line. Let's look at the second example.
Equation. Yeah, really small.
Smile. And now suddenly nobody wants the picture. No, it's not good.
We did this.
That was a great photo.
I like Liam's face. Nice, Liam. That's awesome. Francis is laughing. Arthur's like, what's going on back there? This is hysterical. All right. Graph them on the same set of axes. Okay, when you're ready, let me know. You can graph it on your calculator or you can graph it on your actual iPad. Draw a sketch in your notes, though, no matter what. Even if you graph it on your iPad, draw a sketch real quick, please, on your notes.
I have a good method of shading.
Do you?
You can use the highlighter on Notability.
Yeah. You can definitely use the highlighter shade. I would recommend that. That's a good point, Summer.
Thank you.
How do you choose? How do you choose? Yeah, no, I clicked it.
How do you choose what?
On like greater than or equal to, because I clicked that. And
No, guys, just graph y equals. Don't use greater than or equal to on your calculator. We're going to use testing to do it. You could, on your calculator, set it up with inequalities, but
yeah.
just graph it regular lines. I want you to be able to do the inequality part yourself. Okay, don't use the calculator for the inequality part. That's easy. We're just going to test the point.
Plus y equals 1.
Solve for y. If you're going to use your calculator, you got to solve for y always. So that you have to do on your own, yeah. So there should be an intersection of these two if you solved correctly for y equals. The intersection may occur off the graph. No, it should be on the graph if you have a normal graph. If you hit zoom 6, after you put the two equations in y1 and y2, hit zoom 6, it should show up somewhere on there. Zoom 6, remember, is negative 10 to 10 graph.
Where's X? Got it.
X is above the apps, I think.
Yeah.
Yeah, there's your intersection. Perfect.
Is it like decimals? It looks like it's kind of like a
Yeah, and we're going to talk about ways to find that intersection on the calculator now. For now, guys, just draw a sketch unless you're actually doing it. If you're doing it by hand, it might be a whole number. Okay, I'm not going to tell you yet, but I want you to see. If you're doing it on the calculator, here's what I want you to do. Actually, everybody could stop and do this for a second. I could show you. There's a way to find the intersection on the calculator without doing any math. Check your answer. You can always do this. It's like, remember we checked on the matrix? Here's how you would do it. Oops. Alright. So look up real quick. Here's the graph, and a lot of you have this on your iPad or on your calculator right now. And we want to find that intersection, which clearly occurs in the fourth quadrant, okay, quadrant 4. And that intersection can be found by pressing the following keystrokes. Press second, then above the word trace, you're going to see calc. Okay? So right here along the top,
This is so
you're going to see trace. So press second trace. It's going to bring up the calculate functions.
You're gonna go to intersect.
And you're going to go to number 5 and hit intersect.
This is so annoying. I never knew which way to go. Enter at intersect.
Again, second, then hit trace. It'll bring up this calculate functions. Then press the number 5 for intersect. Now, it's going to ask you to guess where the intersection is. Just go near the intersection. This will always work no matter what you pick, unless there are two intersections. The reason you are specifying where it is along the first curve, the reason you're specifying where it is in case there were two intersections. Then you're specifying which intersection you want. Just press enter 3 times when you hit the intersection.
Wait, where do we? The cursor.
Just go toward the intersection somewhere. Anywhere. It doesn't matter. Just hit enter once you're near there. Hit enter again on the second curve, and then hit enter to guess.
It says like X equals
So, and then intersect, right?
It should be.
Why is trying to be equal?
It should be 1.33 and something else. It should be. What do you guys get for an exact number for the intersection? 1.33?
And then Y equals negative 1.6.
Okay. Yes.
Wait, do you need to flip this?
Shh, guys, stop. You need to ask questions one at a time. Go ahead.
This calculator, never mind, it's irrelevant to.
Okay. So, Arthur,
Wait, do you need to put the negative 2x in?
you need to solve for y no matter what you do.
So that's the end of it.
But I put graph, it says it.
So it means you have something up with your calculator. That's all right. Have you let anybody use this? Do you share with anyone? Oh, your window range. Zoom 6, whenever that happens. When it says window range error, it means somebody changed your window settings. Either a game was played or somebody did something.
Oh, okay.
So that's your
And then
graph.
how do I-
So to get, I did Zoom 6 to bring up that graph.
Okay.
And then you hit second trace. Okay? And then number 5. Press the number 5, and then estimate where it is with the cursors, okay?
If you like enter 3 times.
It works, yeah. Listen again. The intersection will always work even if you just press enter 3 times because there's only one intersection. But we're going to have later examples in here where there's a parabola and a line and there's 2 intersections. So that's when you have to guess which one or move closer on the cursor. So it doesn't matter for now. Anyhow, back to the problem. Why did I put a dash line for that one? For the first one, why is it dashed? You should come after because I need to keep going for now, Arthur. Yeah, so in this one, we've got a greater than inequality, so it's going to be a dash line. In the bottom one, though, it's less than or equal to. There's an equal to part, so it's a solid line. So this is the red one here, and this is the green one, the blue one, the second one. So this is blue. If I use my colors, I'll change it so you guys can see. Guys, if yours isn't crossing, it means that you made a mistake somewhere solving for y or typing it in. You should look at your neighbors who worked and see.
It like crosses not on a point, just on a dash.
Okay?
That's allowed. I thought I had to cross it like a.
Why can't you have a decimal solution? Come on, that's all right. Guys, solutions of any equations can always be decimals. The solution happens to be a decimal here, okay? Don't let it bug you out. Okay, I'm using red so you can see. There's my colors. Now, let's continue. How many regions have been created? How many regions have been created from these 2 lines intersecting?
4.
Yeah, 4. Bottom, top, left, and right. Does everybody see that? You have 4 regions that have been created from this. Now, here's what you want to do. You want to test the origin again, but only in one of them first. So let's take a look at the blue graph. Either I can shade, and you don't do this please, either you can shade above, or you can shade below the blue graph. Either way, above or below. Why can't I get rid of what I just did? I don't know. Okay, we're either going to shade above or below the blue graph. So let's plug the origin into the blue equation, which is the second one in our case here. Okay, so again, plug in 0, 0 into this. You get -3. Guys, are you having trouble? Please, just for now, you need to stop. Just go along with it. I'll come back and look at yours. If your calculator's messed up, I can't help you at this moment, but I will. If you plug in 0 for x and you plug in 0 for y, you get -3 is less than or equal to 0. That is true. That is absolutely true. -3 is less than or equal to 0. So the blue line has a shading region above. So shade this with a blue color or one color in that direction. And follow what I'm doing, please. Shade it the way I'm shading it like that. Okay? And I know it's a little bit confusing at first, but just shade above in the same direction. Make your lines parallel to the boundary. Okay, here's our boundary again. Here's our boundary. Now, go to the red one. And for the red one, if we test the origin, we're going to see 0 is greater than 1. Is that true? No. It is not true. So we don't shade this side. We don't shade the origin side because that was not true. So we have to shade this side. Again, the origin occurs below the red dashed line. Barely. You can barely see, right? Again, look at the x-intercept. It crosses between 0 and 1 right here. So the origin, when we test it, is just below this red dashed line right here. And it was not true, so we shade above it. Where is the overlapping of these two sets? Which region? Top, bottom, left, or right? Top. That's it. No, again, we have, there are four regions are created. This is the top region, this is the bottom region, this is the left region, this over here is the right region. Okay, so it's only the top region. So our solution set is up here. We put a big S there to represent solution set. Okay, so the final answer is everything in this triangle, really. And I'll highlight it in black. From here to here, and a dashed line here. Okay, everything inside of this angle. Okay, everything, and I'll use the cursor so in the video you can see it. Everything inside of here. That's our solution set for this problem. So when you graph systems of solution sets or systems of linear inequalities in two variables, it's just like we did with the last example. It's just like it. But you need to then look for where they overlap with one another. Where they overlap. Is that clear? Let's take we don't even have time, but let's take a quick look at the next example. What I would like you guys to do is try this one. The first two are vertical lines. Remember we talked about vertical lines being x equals? That's what the first two are. The second two are normal equations. Graph all four of these, and you're going to notice you'll get a polygon. And look for the solution. You can do the homework from this. Okay, so definitely do the homework tonight on 3-7. Try this one on your own. I'll put up a video for the recording for this. Okay, you can look at the video for this tonight.